that has arrows from one box to another, and the arrows tell you which direction to head with your methods. And you have to start this with the graph. So here you have a graph, and you have to write it in equation of the graph. That's the first thing that we're going to do. And if you notice here, there's two arrows that stem off of this. They go to what's called factored form, and the other goes to vertex form. There's a third form, general, sometimes called standard form, that you are probably most familiar with, but you can't actually start there. You have to start with these other two forms. Doesn't matter which. I'm going to do an example from either direction to help you. And there are a couple of very important parts on this shape, and we'll go ahead and first identify those here. The most important part is right here where it turns. Go ahead and put a little dot there, and then the name of that spot, it has its own vocabulary. It's called vertex, and I'm going to go ahead and label it. The vertex is -4, -2, and those numbers right there are going to be very important to the first form that we're going to explore. And so in the formula that I'm going to show you here, the H number is going to be -4, and the K number is going to be -2. H and K are the X and the Y of the vertex, a very important XY pair. And when we go over here to this arrow, we'll follow this and we'll write this form. But we have to first know, there's a piece of knowledge you have to have, that the generic equation goes like this. Go ahead and write it here in this little corner. X squared minus H plus, okay? So it looks like that to begin. And then if you can see, well, there's the H and there's the K. We're just going to put those in the correct places in the formula. And then A is a vertical stretch factor. It controls how tall or skinny the parabola looks. We don't really know what it is immediately, so we have to leave it as A. X minus -4 getting squared, and then -2. It looks like that. If we plug the H and the K number in, notice that the default equation, it starts with the minus sign, and then the -4, there's two negatives here. And so we could actually take a moment and make that look a little better here. X plus 4 getting squared, -2. Looks pretty good, but we don't know A. We need to figure out A. And in order to do this, you have to plug in some information here. We are going to plug in a point xy, and solve. That's my and symbol for that A stretch factor here. So the question then leads us to, well, what point should you plug in? You can't really use the same point again, so don't plug that back in, or things will just all cancel each other out. You have to use another very easy to read point. So if you look at this shape, are there any other very easy to read points we can use? Probably. I'm noticing this one right here. This is a good one. We could use this one. It won't matter. Those are, I can see those are very easy to read. Everything else will be a good guess, but it won't be very accurate. So let's go ahead and use this point, which is -3, 0. And we'll plug that point in. We know it's on the parabola, so it's got to work out and solve for this A. The Y number, so the Y is going to be the 0. We don't know A. X is going to be -3 in this instance. There's a +4 because of the formula that we've got so far, squared -2. Okay, there it is. The 0, the -3 in the X, 0 in the Y is plugged in. That's the A. We're trying to find that. Now this is the order of operations. We're just going to go ahead and clean this up a little bit. -3 plus 4, 1. So inside the parentheses, which we operate first according to PEMDAS, and then we're going to square that, so 1 squared is still 1. And so this is 1A, or A times 1, or just plain A. And then the -2 is later. Okay, now you could go ahead and add 2, but maybe you already know, like something -2 equals 0. So the A is going to be, it'd have to be 2 in order to make that a true statement. 2 minus 2 is 0. Okay, so all this work here, this is kind of a new skill. It's come up in a couple different times this year, depending on if you've tackled all the problems thus far. This has come up in the logs equations too. Let's go ahead and write the final look at this. The vertex form is going to look like this. It's this form right here, but now we actually do know the A number. It's 2. So go ahead and put A as 2. X goes back to being variable X. plus the 4, because that's where the vertex is, minus 2. There you have it. So we have the equation in vertex form. That, if we graphed it on our calculator, it would produce this shape with exactly those points on it. Okay, now we could instead, if we didn't have that information, the vertex was too hard to find or was not available to us, we would instead have to go the other direction into factored form. Factored form requires different information. We'll go ahead and write that down too. It looks like this: y equals same a, parentheses, x minus r1, parentheses, x minus r2. And r1 and r2 refer to the other two very important points on this shape. It's where it crosses the x-axis, the roots, which is negative 5. But these 2 points right there, those are the roots, and it doesn't matter which one's r1 and which one's r2. They're interchangeable, which one is which. So I'll just label it like that for no better reason. R1 is this root, R2 is that root. We can see those numbers here. If we put them into place, y equals a, x minus negative 3, and this one, the minuses are part of the formula, so don't think that the minus is already because it's there. It's not. It's got to be a double negative in this case, negative 5, which the double negatives we can, of course, write them in the better looking form, x plus 3 and x plus 5 looks better. Now, same problem as before. Nico?
Does it matter which one goes where?
Doesn't matter. If you want to call it R1 and R2 or R2 and R1, it's the same. Okay, we don't know the A number, so I realize we know it because we did it from the other direction, but pretending you don't know it, we're still going to do the same thing. We're going to plug in a point, xy, solve for A. Okay, go ahead and write it there, because in some cases you'll be going this direction, in some cases you'll be going the other direction. And it is the same skill though. So if we plug in a point, if you notice here, we already used the 2 roots to begin this process. You can't use those again. Okay, so the other, we use these 2. Now we can plug in the vertex because it hasn't been used yet from this angle. You haven't used it on this to find a factor form. So we'll go ahead and plug in the x and the y are going to be specifically negative 4, negative 2. Negative 2 equals a, x is negative 4 plus 3, and negative 4 plus 5. Okay, now we solve for a. So same as before, but it's just slightly different details. If we go ahead and clean this up, negative 2 equals a. This is negative 1, and this is positive 1. So you've got a times negative 1 times positive 1 is the same as just a negative a. This statement says negative a equals negative 2, which implies that positive a equals positive 2. Now, we already knew that from the other direction, but there you have it from this angle. And if we go back up to the box we're actually trying to write it as, y equals a is 2. We're just really going back to this step of the process right here, and now we did a little side quest to figure out a was the number 2, so we can put it in place. And then we'll rewrite the rest of the format of this equation. X goes back to variable x plus 3 here, and then variable x plus 5 looks like that. That's done. Okay, from the graph, those are your 2 choices. You're either going factor form or vertex form. From there, we can do a little bit of fancy tool work to convert it into the final form, the general form. So this one here, I'm going to turn sideways. We'll go ahead and we'll follow this path to get us to the general form, sometimes called standard form. And y equals 2, x plus 3, x plus 5. And we have to convert that. Now, in order to do that, you should recognize the double parenthesis implies we need a box method to multiply that together. We'll go ahead and multiply x plus 3 and x plus 5 together in a box. Here we go. X plus 3, x plus 5. I'm ignoring the 2 in front, so I'm just doing the double parenthesis part of this. It's going to be x squared is 3x's here, 5x is there, and a 15 in the corner. Meaning that this is the same as the 2 comes back. I didn't forget about it, it's coming back in. But instead of the double parenthesis, I'm going to write the equivalent x squared plus 8x's, when we combine my terms, plus a 15. All right, from there, we can distribute it to. Okay, it distributes to all of the parts inside that parenthesis, so essentially everything in there is going to get doubled. Now that leads us to this equation here. If we doubled all of those items, it would go 2x squared plus, double the 16x plus 30. And that's now in general form. You've probably seen a lot of equations that are in that form, that when you graph them, they make parabolas. And so it's 1 of 3. Okay. Oftentimes that's the goal. However, since this is a note-taking exercise here, I'm going to do the same sort of a thing, but from the vertex form. So we'll go this avenue and go this direction with all of the information, and it'll be very similar. But the x plus 4 is getting squared. That's to be multiplied by itself. It looks like that when it's getting squared. And then there is this lingering -2 after the fact we'll deal with later. Again, there is a double parenthesis box method required. I'm going to ignore the rest of the parts and just do the box method portion of this. And that would be x plus 4 against itself. X plus 4 here. X squared, 4x's, 4 more x's, and a 16. And so this is the same as, I'll bring back the other parts of it. Instead of the double parenthesis, it would be equivalent to x squared plus 8x's plus 16, and then don't forget the -2 later. There it is. Okay, from there you go, well, it's kind of the same thing. We're just going to distribute the 2. Only difference is that there's a -2 that will also happen. Order of operations, though, we would multiply this. So I wrote 8. This is supposed to be 16. Mess that one up. Okay, 2x squared, 16x's, and then 32, but then -2. That's how we get the 30, which is the end result, but from this direction. Okay, so now you have a way to convert it from either one of the forms into this form. You got to have a way to convert it back. So what if the information you're presented with, instead you start here, then you have to get to the other form. So you should be prepared for that as well. There's a couple different methods. If you know, there's two different ways to get here. I'm going to start you on the quadratic formula. It's a little bit easier. There's a homework assignment we'll do later about specifically to factoring. I think I'll give you that information then. Instead, let's do the quadratic formula. You have to know in the quadratic formula, there are some A, B, and C's that get plugged into the quadratic formula. It's a magical formula that solves when you have a x getting squared and a regular x that's not. Those are not like terms, so there's not really any easy algebra to do. Okay, we're going to use the A, B, and C here. This one's a longer process too, so I'll write it like this. If you remember your quadratic formula? It starts as negative b, and then you're going to do it twice. There's a plus and a minus, because there will be 2 answers. And then square root, that's my square root, of b squared minus 4ac all over 2a. And I'm going to have you put in, if you do this by hand, without a calculator, I'm going to have you put this in parentheses because you'll make fewer mistakes if you do this 4ac business before you subtract off of b squared. Students make mistakes sometimes in doing it by hand, but we'll run through it with a calculator. All right, we've identified A, B, and C. That's the quadratic formula. You do have to have that memorized, or at least you have to know what it. If somebody says quadratic formula, you have to know that that's what you should look for. If we put in the particulars here, x equals negative b is negative 16, plus or minus square root of 16 squared minus 4 is part of the formula, times 2 times 30. Those are specific to our problem. And then 2 is also part of the formula times a is 2. Okay, so there you have the look of it when the things are plugged into the right places. We still have to go through and maybe clean it up a little bit. Let's do, I'll take a extra step. Actually, maybe I'll do it, I'm gonna do it up here. So I think I'm gonna need all the space. Okay, x equals negative 16 plus or minus the square root of whatever this, okay, 16 squared. Let's go ahead and do this real quick. 16 squared minus 4 times 2 times 30. Oh, 16. Okay, so that's going to be the amount that's just under the square root part of this problem. So this is going to be negative 16 plus or minus the square root of 16. A lot of 16s in here. Divided by 2 times 2, 4. Square root of 16 is, of course, plus or minus 4. And now we're going to take care, so really nothing was different until this point. We're going to do it once with the plus right there, and then we'll do it again differently with the minus there. So you'll kind of do it once with the plus and once with the minus. This equals negative 16 plus 4 over 4. And x is negative 16 minus 4 over 4. And this is negative 5. And this is the negative 3. There we go. Okay, so if it's been a while, or maybe you've never been through the quadratic formula procedure, we will do this a little more specifically, but there you at least have one example of the steps. Now, what did that do for us? What is the usefulness of negative 3 and negative 5 as answers? They don't actually get you to this factored form. You have to recognize all they do is get you R1 and R2. You still have to know that the A number is 2 because it's A is the same A as 2 here. Yeah, you could just, I don't know, I have to copy pass. Give me a moment. So we're going to bring down the same 2. If we go and write this, 2 is from the A from before, and then it's going to be the negative 3 and negative 5, you can see come into play here. Is what we solve for us. That's what the quadratic formula gives you. You still have to know where to put them. Okay, so that's all of this side of it. I'm going to skip factoring, like I said. I'm going to go over here. Instead, we'll pretend, well, what if we're trying to get back to vertex form? And there's 2 different methods here. And again, I'll just show you one today and another later. So we're going to do this, the far right one, x is negative b over 2a, and then y equals plug in x. Now, what you're doing with this is you're finding the h and the k. So the h and the k come into play in the vertex form. This is the way that we're going to shorthand get them. Negative b over 2a, that's the first part of this formula. Negative b over 2a is just this piece without the plus minus business. Okay, so we're going to solve this. X equals negative b over 2a, and h is a very special x. It's the x of the vertex, which is specific to this problem, negative 16 over 2 times 2, which is negative 4. Okay, so we found the x of the vertex is negative 4. And then to find y, we'll plug that in. Now, when I say plug it in here, I mean right here. We've got a formula, equation for this parabola. If we replace x with the specific number negative 4, we can calculate what y equals. We'll go ahead and do that. Y equals 2 times plug in negative 4, 16, plug in negative 4, and I'm kind of out of space here, plus 30. So let's see if we can read that. Okay, and if we go ahead and do that, let's try it. 2 times negative 4 squared 16 times -4 plus 30. -2. Okay, that tells us the y of the vertex, which has a special letter k. It's all very confusing. All right, now again, well, what does that get us? What does that do? We found the vertex, -4, -2. Some of this might be kind of redundant, but trying to connect the parts. You still need the 2 as the a number, observable from the general form equation, and then we're going to plug in the h and the k. So all that gave us was the h number and the k number. You still have to know how to put that in the correct place. Okay, so we're going to pause this side of this note sheet at that, and at the very end of this description here, I can come back and readdress any of those parts if need be. But let's switch over. You got one more side of this, and we'll go through these parts as well. This is the same shape here, and we have vertex, roots, and then in the middle of this, imagine placing a mirror right there. You could, if you know one side of this, you would know the other by way of symmetry. And there's a name for this special point in the middle. Go ahead and make a dashed line through the center of it. It's known as the axis of symmetry. Okay, that's the axis of symmetry. It's the only new vocab here really on this side of it. Other than, I should also mention root. It's a common name for this spot on the shape, but it also goes by a couple other names I want you to be aware of. Solutions. So if a problem is asking for the solutions, it's really asking for the roots, as well as the word zeros. So those are some different vocabulary that mean the same thing. Those are interchangeable. Okay, let's go ahead and we will add, later we'll add a part up here, but for now let's go back to these 3 different forms that we have. And if I say factored form, you should know which one that looks like. How many parentheses are there in factored form? This is the double parenthesis one, meaning that it looks like a x minus r1, x minus r2. That's that one, which for this particular parabola was 2x plus 3, x plus 5. Okay, general form. If I say that word, how many parentheses does that have? Should be visualizing here. Well, that doesn't have any. That's the one that goes ax squared plus bx plus c. Specific to our problem, 2x squared plus 16x plus 30. And the last one, the vertex, that's the one with only one getting squared. Okay, so those are the 3. Now, from each of these 3 directions, you have to be able to find all of the important parts. So this unit gets a little bit overwhelming with all of the different ways to find the same things, and we'll go through that here. So we'll hopefully sort it out. How to find the roots? This occurs when y equals 0. We'll go ahead and put y equals 0, and then 2x plus 3, x plus 5. So we'll start here. And then maybe no algebra required. Can you just think of 2 numbers that you would put in place of x that would make it 0 out? And you can say, well, one of them would come from here. If x plus 3 equals 0, the whole thing would be 0 because it's all getting multiplied. So that means, in this case, x would be -3 to cancel plus 3. From this parenthesis, x plus 5, if that were 0, the same thing would happen. The whole thing would be 0. And so that means the x could also be negative 5, and it would also have the same answer of 0. So cancel plus 5. Okay, so that's how you do it here. If you have this method, this one here, I'm not going to write it out, we did it on the other side. This is the quad formula, whereby A equals 2, B equals 16, and C equals 30. And I'm just going to write that there. We won't add any more because you have it on the other side. And then the last one is probably the trickiest. We're going to put 0 into y, 2x plus 4 squared minus 2. Okay, and this one right here, there's only one x in the problem, so there's no reason to try to do any kind of a box method. We're just going to algebraically solve this. So if you were solving this, you would add 2 to both sides. 2 equals 2x plus 4 squared. And then you would divide by 2 to cancel this multiplying right here. And you would get 1. Okay, so you have 2 algebraic steps. And then right here, this is the trickiest one where most people get caught. There's actually 2 answers. We kind of already know them from before. Something plus 4, if you square it, makes 1. There's 2 numbers. And if you go through this too fast and you just go through the next step would be just square root both sides. Square root of this would cancel the squaring. But this is where you have to do, this could be a positive getting squared and be a 1, or it could be a negative being squared and also get us an answer of 1. So we have to do this twice. Square root of 1 equals x plus 4, or it could be the negative square root of 1 equals x plus 4. Both of those are viable. And then we'll subtract, in either case, we're going to subtract 4. And from this first answer, x equals, let's see, negative 3. Second answer will be negative 5. Okay, so that's the hardest one. We have to practice that one. It's probably not self-explanatory from this little series of steps, but there at least you have it for later. Okay, I'm going to go ahead and back up to this one here. Well, how do you find the y-intercept? This one's a little more straightforward. It occurs when x equals 0. And so we're just going to plug in x equals 0 in every case here. This is going to be y equals 2, 0 plus 3, 0 plus 5. We know what the x is. We're going to solve, we're going to calculate what the y is. In order of operations here, we'll just, this is 2 times 3 times 5, really, which is 30. Equals 30. Okay, so the y-intercept is 0, 30, and then there's the method from that form. If you instead have this form, then you should notice, well, if you plug in a bunch of zeros, this whole first part of it is 0. And then the only thing left is the plus 30 here. This right there is stays. So we get the 30 from that last part. And then the final one here, order of operations, we would square this. And then we would multiply. So we get it from that. Okay, so that's how to find the y-intercept. We're going to find the vertex from every form now. Okay, back to the first one. How do you find the vertex? Well, it's a symmetrical shape. So we're going to find halfway. X is halfway between the roots. I should actually write that. Okay, meaning, like, here's what I mean by this. If you know where the roots are, these 2 points right there, you should be able to figure out the middle is going to be the x of the vertex. Okay, well, so what's halfway? Well, that would be x equals -4. Plug in x equals -4 to find y equals -2. I don't have a lot of space to write that here, but essentially what I mean by that is if you go back up to your equation, you're going to plug in x as -4. You're going to compute that y equals -2. Okay, so that's implied in this method. I don't have enough space to write that in there. And then if you instead have general form, x equals this is the -b over 2a portion of this, so x equals -16 over 2 times 2 equals -4. Plug in x, y equals -2. And again, that last part here, it may not be self-explanatory, but we'll come back to specifically what that means after this note part of these notes. Okay, the last one here, y equals 2. Okay, this one is not really algebraic at all. I wrote the equation and then I wrote it in the form that it's supposed to be in with a minus here, so that the plus is actually expressed as a double negative. And you have to know, well, if you know where to look, then you're done. That's the h and that's the k, that's the vertex. Okay, so that one's just deconstructing the form. Okay, and the last part of this, how do you find the line of symmetry? Okay, finding the line of symmetry is kind of a code for just find vertex. Okay, so it doesn't matter what form you're in. Really what you should do if you want the line of symmetry is, well, just go ahead and find the vertex. Because it's going to be the x equals -4. It's right there. It's there, and then it's right there. Okay, so how do you solve it? So this is kind of the same thing. When I say solve the equation, really you're trying to find the x, what x makes it equal to 0. And so this should be kind of a code word, a clue for you to just, well, find the roots. And that's true for all of these. -3 and -5. We've done that plenty of times on this paper already. Okay, so there you have, that's the whole thing.